Hi, in this video we're going to talk about some of the other database options available, and in a departure from the way that we've been doing things, I'm going to go ahead and cover more than one database option in this video, just so that we can get through some of the more easier ones really quick and then start focusing on the more interesting database options that are available. In order to do this, I've already got the scripts created, and I'll just explain what each of them do and why they are important, if at all they are. So again, we're still talking about database options. So if you want to look at your database options, you go into the database properties and you have options here. Do keep in mind that when we're talking about database options, there are more than what you see over here, just that you need to use Transact SQL for that. So the ones that are not documented here will also be covered later on in the series. For now, in this video, we're going to talk about some of the less obvious ones, such as ANSI warnings, ANSI padding. We've also got things like the cutoff date for the date. So if you look over here, we've got 2-digit year cutoff. They're fairly straightforward. They're self-explanatory in a lot of cases, but it's important to understand. We'll also talk about not arithmetic, but numeric roundabout. So let's have a look at the first one. So if you look over here, we've got ANSI padding. Now, as the name suggests, padding basically means adding more data, adding more stuff. So the way that you can understand this is, if you look over here, I've got a varchar column and a char column. Now, if you know the difference between a char and a varchar, what it basically means is, when I say 10 over here, even if I type in just 4 letters, it understands that it's supposed to be 10 characters total. So it'll just keep stuffing it with additional spaces. So to understand that, let's go ahead and run this really quick. If you look over here right now, I've gone ahead and set ANSI padding off, and the Microsoft documentation clearly states that ANSI padding should always be set on, and if that's the case, then we really don't need the setting. It should just be on by default all the time, and hopefully that's something that they'll rectify later on. Having said that, if you look over here, we got my char and my varchar, and varchar, obviously, as its name suggests, is variable in length, so it adjusts or trims the spaces as needed. Char, on the other hand, doesn't. So if you look over here, I'm trying to insert data into a table called padding, and in the char column, I've got the word for, F-O-U-R, followed by 2 spaces. So I've got like 6 characters. And in the perfect world, what happens is that the data length, which shows the amount of space occupied by this data in that row, should reflect as 10. However, you'll notice that when I set it to off, it reflects 4. So it's not really storing the data in a char format at all. It's actually storing it in a varchar format, because you'll see that the length of the text is 4, as well as the fact that the data itself is 4. And you'll see the same thing happens for varchar, which is kind of expected. We know that that's how it works. So that's straightforward. What you'll also notice is that we added some spaces at the end of the word, and they've been trimmed out. So it's automatically trimming the text. But on the other hand, when you set it to on, let's see what happens. Now you see, when I set it to on, this is the behavior that we expect from a char data type, where when we insert data into it, the char basically stuffs spaces until it reaches the maximum length. And that's why I guess Microsoft is specifically recommending that ANSI padding be on, because otherwise the char data type doesn't really perform any differently from the varchar, other than the way that the data is actually stored. But in terms of the size of the data, etc., it's not kind of the way that you're used to seeing it. You'll also notice that when we do ANSI padding on, trailing spaces in the text are actually respected. So you'll see here that for the varchar, even though the trailing spaces exist in the data, they're actually saved. So you'll see that the length of the text says 4, but the 2 spaces that I've added also reflect over here. So this is a big departure from the way that ANSI padding on and off works. In ANSI padding off, trailing spaces, leading zeros are completely ignored. But in ANSI padding on, they are respected, even if you can't actually see them when you look at the length of the text. So the data in the actual storage in the data page is still saved as you have inserted it, just that you don't get to see it. So that's basically ANSI padding for you. So again, Microsoft recommendation that it should be on. So I'm guessing there's really not much we need to do there other than leave it on. And it kind of helps us stick to what we expect that behavior to be. The next one is concat null yields null. So what that basically means is, when you try to concatenate 2 variables or 2 columns where there are null values in them, how should the null be treated? The example is fairly straightforward. A common example that you will find in most of your database systems is you got a first name, a middle name, and last name, and the middle name is null in this case, which is common for a lot of people. So if I set concat null yields null on, you'll notice that if a null is concatenated, then the entire thing becomes a null. So this respects null as ANSI has defined it. So that's why concat null yields null is always going to be on. Because ANSI basically mentions that a null should be treated not as a value, and therefore anything that touches a null should become null in itself. And on the other hand, you'll see when we set it off, the null is completely ignored. So it's not like the value null is being saved over here, but you can see that the concatenation doesn't throw an error. And there are obvious cases where you might want to go ahead and have this behavior. For example, this is a good case where the middle name is something that we don't want to take into consideration, so we would like it to be ignored rather than just show a null value and then handle it separately. But on other scenarios, it doesn't really make sense. So it's always a good idea to check your data and see which of these settings you actually want. The next one we have is, let's do this one, Numeric Roundabout. So in Numeric Roundabout, what happens is it's essentially about just letting you know whether there is a rounding error that's happening. Now, as you know, we have precise and imprecise data types. So float is an example of a data type that might not be precise. And then we've got a precise data type like decimal, where the number of decimal places is respected. However, what happens typically is when the number of decimal places is insufficient, the last one usually gets rounded up to the next closest value. And you are not usually aware of it because it doesn't really matter in terms of the context of the number that you're working with. But at the same time, for scientific systems, even for a lot of financial systems, storing the decimal places accurately is a big deal. And in those cases, you might prefer to go ahead and do numeric roundabout off. So let's have a look at this and see what this actually means. If you look over here, I've got a number. It's a fairly big number, and I've got 10 decimal places, which is obviously not enough to handle the number of decimal places I have here. So when I say numeric roundabout on, what it basically means is when I try to insert data into a decimal data type and the decimal places are insufficient, I get an error message, which I therefore can handle and let everybody know that we are missing out on some decimal places in this particular query. However, on the other hand, when I say numeric roundabout off, what happens is even though I'm not able to store all the decimal places, I don't get an error message. It just simply stores as much as it can and the rest of it is ignored. So this again is usually related to the fact about how you want to handle things when data goes missing. So this is again something related to truncation errors. You want to know when something is being truncated. You don't want to just accept it as it is. So those kind of situations even exist not just in cases where you're dealing with strings, but even when you're dealing with numbers. And this is an example of how numeric roundabout would work in helping you. Next, we have the 2-digit year cutoff. Again, a database setting that's not really a database setting because you change it at the server level. However, it's something that's available on the property screen, so I thought we should cover it. Now, typically what happens is when you write a date like this, SQL Server could potentially get confused about whether you mean 1948 or 2048. So for that reason, there is a cutoff date that's set. For example, if you look over here right now, if I look at my database, I would find that my cutoff date at the moment should be 2049, which means that if I type in any date less than 2049, SQL Server automatically understands that I mean 2048, if you see over here. However, if I do 2050, it doesn't really understand that I mean 2050 because it's beyond the cutoff date and it goes into 1950. If you want to change this behavior so that you can type in 2-digit years and it understands which year you're talking about, you would need to go into advanced options in SP configure, and after that go ahead and change the cutoff date. So you can see here I've changed the cutoff date to 2060, which means that going forward up till 2060, if I just type in the 2 digits, it understands that it means the 20 basically rather than 19. A quick demonstration of that would be something like this, where now if I type in the same date I typed before, SQL Server doesn't misunderstand and try to make it 1950. It understands I mean 2050, and that's handled because of the new cutoff date. Next, we're going to talk about ANSI warnings, which is the big one. So in ANSI warnings, basically what you're trying to get with the data is how SQL Server is supposed to behave when any kind of default ANSI behavior is ignored or bypassed. And some simple example would be when you try to divide by 0, should you see an error message or not, or when you try to do an aggregate, and if there are null values, do you let the user know that they have been ignored? So let's have a look at this. It's probably easier to understand this when you actually run the code and see it behaving. So I've got a database here. I'm just going to call this airline database. So let me just click this one here, and I'm going to go ahead and change the database to saying that ANSI warnings are off, which means that non-default behavior. So I'm also going to set it at the session level, because as you might know from previous videos, database settings like this usually don't matter much, because the session level variable or session level settings bypass or override the database preferences. Now I don't have the database a table created as yet, so I'm just going to go ahead and create one right now. And inside this, I'm going to go ahead and insert my data. So you'll see that I've got the data here. I've got one number here, and then the other one has a null. The second row has a null. Now when I say ANSI warnings is off, what that basically means is that if you look over here in my session right now, you'll see that it's set to 0, which means that ANSI warnings are off. And when I do ANSI warnings are off, if I execute this, you'll see that I get a divide by 0 error. And because of the divide by 0 error, what happens basically is that it just skips that and moves on. So I get an error message, but I don't see any results. I don't see any behavior, which is kind of misleading, because when you look at the documentation says that divide by 0 errors are ignored, which it actually isn't. So that's something you want to watch out for. The next thing you want to do is, if you look over here, this is a sum operation that I'm doing on 2 columns. And again, you'll see that when the sum operation happens, I don't get any error message about the fact that nulls have been ignored, because I know there are nulls over here. So for all I know, this is basically summing up the data, and I don't even know for a fact that some of the data may be not correct or exactly what I expected. The important thing that you want to understand here is how the rollback is affected. So let me just try running this complete thing all over again, but as one batch. Now when I run this as one batch, you will see that as soon as a divide by 0 error is encountered, pretty much everything comes to a stop. It doesn't even try to do the sum operation. It doesn't even run the select statement. So everything kind of stops and jumps out as soon as the first warning or first error is encountered, which means basically that it doesn't even try to execute the next set of commands. And this is the important difference between how things behave when you set ANSI warnings on. So if you look over here, as soon as I run this, the only thing that happens is I get to know what my ANSI settings are, and after that, pretty much immediately the divide by 0 throws an error and everything comes to a stop. But on the other hand, when I do ANSI warnings is on and run the exact same command, you'll notice a different behavior. When I run ANSI warnings on, you'll see that the divide by 0 error still occurred, but after that the rest of the batch still completed to go through successfully. So you'll see that I've done the sum operation, and along with the sum I get the warning that the nulls have been ignored. And once the sum operation is completed, I also get the statement for the select, which is basically just something to show you that other operations continue, which is not the case when you're doing ANSI warnings off. In ANSI warnings off, pretty much nothing happens after that point. So you can run it like this. If you look over here, when I run this with the sum operation, everything looks fine, because both of them just went, just give me a second. I need to go ahead and set it off first, because at the session level it's already enabled. So let's say that the divide by 0 never occurred in the first place, and I'm just doing the sum of the operations with the select statement. In this case, because there is no error, everything continues perfectly fine. But the moment an error occurs, everything goes for a toss if your ANSI warnings is set to off, because SQL Server just decides that, oh well, error happened, I'm giving up. Which is not the case when you work with ANSI warnings is set to on, where SQL Server handles the error, or at least warns you about it, and then proceeds with the next operation. So these are the important settings that I wanted to quickly cover to you, keeping in mind the fact that we've got the basic stuff out of the way. So in the next couple of videos, I'm going to show you some of the more interesting fun database options, things like delay durability, etc., that you'd actually find useful in a couple of performance tuning sessions, because most of the stuff that I've shown you till now are stuff that should be just enabled. They've got really only one correct answer, and as soon as you do that, you can just leave the database as it is. The ones that I'm going to show you in the rest of the series are not necessarily just a direct solution, and there's a lot more thinking involved in terms of whether the solution you're choosing is the right one for your system. So stay tuned for that. I hope you've enjoyed this video, and thank you for watching.